current trend in AI. So, but my research area is not directly on AI, but I usually I usually apply AI, machine learning, all this kind of tool on my research area, on my different research, what I do in my academic career. So one of the research work I will present to you, which having the AI component, which has in this work the AI extensive amount of AI component has been used to implement this work implement this work on the real environment. Okay, so the topic of this work is the smart home control system control through activity recognition. So all of you know the smart home. Currently, the concept of smart city, smart home, all has been arised. There are few implementation. Giant companies like Google, Facebook, Google, Apple, Amazon, all they have invented and implemented different kind of smart home control systems, and they are nowadays being used in many different smart cities, smart homes around the world. So the controlling smart home, so different controlling way has been used, but there are very limited work. There are very limited implementation also. The controlling smart home through activity recognition. By recognizing the activity of the occupants inside a room or inside a home, and the controlling the different kind of appliances or different kind of electronic instrument inside home. This kind of implementation is very limited and has not been used so far, or has not been widely implemented, widely deployed in our smart home, smart cities. So this work is to control. This work is to control smart home through activity. How the activity of a human being, of the occupant, will be sensed by using AI, and that will be used to control the smart home system. This work is aimed for this. Okay. In my presentation, I will first introduce what is smart home and what is activity recognition techniques to control the smart home. Then I will discuss about the design of our system. Then I will talk about how we have implemented the system. I will also show you a small test bed of the implementation. Then I will present some evolution results, how our proposed system performing on the real environment. This result has been corrected from the real deployment, from a lab scale deployment. Okay. At the end, I will I will give you a conclusion of the presented work. Okay. So first of all, what is smart home? Smart home is a family design concept developed in recent decades. It aimed in smart home is the family design concept that it being used in family, in office, many different places. Smart home being used, that different people for the different purpose. The smart home been implemented, smart home been designed, or smart home been deployed in many different environment and has been designed as per the requirement. Okay. So it is being used from a few years back, maybe around 20 years back. But nowadays, earlier it was in the theoretical stage. But nowadays, a few giant companies, as I told, that Google, Apple, Amazon, all these companies are heavily involving in this area of implementation as well as research, and they have invented a few systems to deploy as well as the control the smart home. Okay, so it's aimed to build an efficient residential facility and a daily management system for families. Okay, It is here I told families, but it is not only family. It can also be used in the office, different kind of offices to control. It in the smart home basically used for by the family people as well as in the office employees to control different kind of appliances, different kind of electronics devices deployed, installed inside the home, which will give the better environment, better facility for the occupants inside the home. So far, there are five control methods being used in the smart home. Control method been implemented or been designed for the smart home control. The first one is the local control. Local control means the control unit is inside the smart home itself. The occupants or the people inside the smart home can control the electronic appliances or devices inside the smart home through a local control, like a controller. What you can see in our homes in India, we have control regulator for fans or some kind of switchboard for turning on of lights or changing the intensity of the light. So those are the local control of the inside the home. Okay. Then another is the remote network control. Now the all the devices inside the electronic devices or appliances connected over network through a access point, or it may be the Wi-Fi network, it may be a LAN network. So all these devices are connected with a network, and there is a software or application installed our mobile phone, like mobile phone or tablet, and all the devices can be controlled from that application through mobile phone or through tablet. Okay, that is called remote network control. Then another is timing control, that we can set time to the devices, or there is a controller inside the smart home where we can set time for each and every devices. So that device will be turned on according to the time schedule, and will be turned off according to the given time schedule. Okay, the on off and the controlling intensity of the light or other kind of properties of the devices will be changed by through some schedule, predefined schedule. That is called timing control. Another is the one sync control, that all the devices is connected with a single switch or single kind of touch panel, where you can touch on a switch or on a control item, which will control the entire smart home with a single click. Okay. Then another is voice control. Nowadays, Amazon has Amazon Alexa or the Apple Toolkit. All this kind of devices has been implemented and being used in the smart home, which basically provide the facility of controlling the devices through voice of the occupants. So all these fives are the available controlling method of the smart home devices and smart home appliances and overall smart home. Okay, so this diagram basically presents uh, a typical representation, typical idea of smart home. Here in this diagram, you can see this is a smart home. The all the devices is connected over Wi-Fi to the mobile access, mobile phone, computer, PC, laptop, TV, audio system, CCTV, tablet. All these are connected in a single Wi-Fi network. Okay. So they can these devices, temperature, lighting, the CCTV camera, audio system, TV, car parking, all this can be controlled through mobile phone or tablet, even through computer also. Okay, and this control can be done over the network from remote places. So maybe you are not present in the smart home, but still you can control the devices over your mobile phone or mobile tablet. So what is reactivity recognition? Now our this work, this idea is controlling smart home through activity recognition. That what is then we have to understand what is activity recognition. The word, the term activity recognition, it itself itself tells that the how to recognize activity of the person, how to recognize the movement of the person, and accordingly a decision will be made to control the smart home devices. It is basically a method of identifying user activities through a series of observations on the behavior and environmental conditions of one or more users. So this is a method basically to identify user activities through series of observation. Observation can be done many different ways, like through a camera, through a sensor, through the changes of Wi-Fi signal inside the room. There are many different ways we can different method we can use to observe, to identify the movement or activity of a user. Okay. Basically this kind of sensors or camera or changes of the Wi-Fi signal, uh, uh, this techniques, this kind of methods being used to identify the behavior or and how the environmental condition of the smart home environment is being changed due to the change of the activity of the occupant. Okay. By this change of the environment and by the this kind of systems like sensors or camera or the Wi-Fi sensors, it basically sense the behavior or identify the behavior of the occupant. And this by identifying the behavior of the occupant, a signal is sent to the smart home devices to control accordingly based on the human behavior. If the person occupant is lying on the bed, if the activity recognition unit identify that the occupant is lying on the bed and his or her eyelid is not moving, and then the system may identify that, may decide that the person is sleeping now. So accordingly the light will be switched off or it will dim, intensity will be low, the TV will be turned off, and the other kind of appliances the will be either turn on or turn off accordingly based on the some predefined algorithm or predefined logic. Okay. So the person occupant inside the home need not to interact with the home appliances or interact with the devices inside the smart home by manually, by himself or herself. The system will identify his activity and control the devices accordingly based on his behavior and activity. Okay. The system can identify only one person in a room. The more advanced system can identify the activity of the multiple person inside the room. Okay. So the preliminary systems which don't have enough stronger algorithm or stronger identification or recognition system, they can only identify one person's movement inside the room or activity inside the room. But more advanced system simultaneously can identify more multiple persons activity and decide the control of the home appliances, smart home appliances or devices accordingly. The academic community mainly provides ideas about three kind of sensors. Okay, so far whatever the research has been done in this activity recognition based smart home control, the theoretically three kind of sensors has been proposed, but all this kind of sensors has not been yet implemented in or deployed in the real systems. What are the three kind of sensors? First, in acceleration based sensor, there is sensor is implemented, deployed inside the smart home. It basically sense the acceleration of the change of acceleration of the occupant inside the smart home. Okay. How acceleration of the occupant being changed, being varying between their movement changes or other activity changes, how acceleration being changed, and based on the changes of the acceleration, the system identify the activity of that, recognize the activity of that occupant, and accordingly control the smart home. Okay. Next one is the vision based. Vision based means the camera is installed inside the smart home. Not only, it may not be one camera, it may be multiple camera deployed inside the smart home. Camera always continuously take video of the person inside the smart home, and analyze the video and identify the activity of the person and control the smart home accordingly. Then last one is the Wi-Fi based. Wi-Fi based, what I told, that the room smart home, basically nowadays, where inside the room there is a Wi-Fi access point, the Wi-Fi signal basically spread over the entire room. Okay, wherever you go inside the room, within the range of the Wi-Fi signal, you can get the network. But it is the Wi-Fi signal is like a spreading like a ocean. Okay, over the smart home, okay, inside the smart home. When the occupant is moving inside the smart home, there is a changes in the of the signal, Wi-Fi signal inside the smart home. Changes happen of the Wi-Fi signal. Okay, this sensor basically detect these changes of the Wi-Fi signal, and accordingly analyze these changes, and accordingly identify the activity of the person inside the smart home, and control the appliances accordingly. So these are the three techniques, three methods, or three type of sensors being used in the smart home to identify activity of the of occupants inside smart home. Okay. First is acceleration based, the second is vision based, and third is Wi-Fi based. Okay. For this design, for designing this our activity recognition system, what we have implemented, we have used the MCU, the microcontroller unit, in the form of Arduino board. I think every of you know the Arduino board. Arduino board is a open source, open hardware platform mainly used in academic environment. Okay, that Arduino board being
Hello,
used.
hello,
Here
hello. Check. My
it is
testing.
being used like a microcontroller unit.
Hello,
Then
hello.
acceleration sensor, we have used JY61 acceleration sensor. Okay, and we have used infrared sensor, grid eye infrared sensor for this system, for implementing the system. Okay, the flow of sensing happens like this, can be described by using this flow diagram. Okay, first infrared sensor, that is the grid eye sensor, identify the presence and location of the occupant inside the smart home. Okay, then if the person, if a occupant is present inside the smart home, then it read the information from the acceleration sensor. Through the acceleration sensor, send the information. Okay, so then this information, acceleration information, is sent to the microcontroller MCU. Okay, and this MCU basically process the acceleration data and send the data to a computer. Okay, computer basically analyze through an automatic algorithm and identify this algorithm, basically AI based algorithm. And computer is running an AI based algorithm, and this algorithm basically analyze the acceleration data and identify the activity of the person, recognize the activity of the person, and send the control signal to the home appliances inside the smart home accordingly. Okay, appliances, it sent the appliances. So activity detection technique, this is the user. First position is detected, presence and position of the user is detected through the infrared sensor. Then activity like sitting, lying, walking, all this different activity is identified through the acceleration based sensor, and then these two data is being is given to the MCU, microcontroller unit, and then microcontroller unit combine this data together and send this data to a computer. Okay, this computer, basically a computer is running the AI algorithm, and it receives the data and classify the data based into the different kind of activities, user activity like sitting, lying, walking, many other activities can be possible, and classify the data accordingly and send the control to the appliances based on the identified or recognized activity of the user. Okay, so this is the developed hardware we have developed. This is a prototype model. This is not the commercial hardware we have developed. This is a prototype, lab scale prototype, but to be used in the commercial environment or a real smart home, we need to implement in a single, in a more integrated format, more integrated manner. Okay, so there are 4 pins should be used in the JY65. This is the JY61 sensor, acceleration sensor. This having the 4 pins. These 4 pins is connected to corresponding inputs to the Arduino board. This is basically Arduino board. Okay, Arduino board has 4 ports corresponding to the acceleration sensor. This has 4 ports corresponding to this acceleration sensor. Okay, so now data set. How now I will talk about this algorithm that which basically classify the activity, classify or identify the user activity based on the acceleration data. This this algorithm basically trained by using a data set. The data set we have used having features of 562 features it having, but the training the algorithm using 562 features is very time consuming and require a huge high performing hardware. So we decided to reduce the dimension of the data set, and we have used TSNE, dimension reduction technique, and we reduced the dimension of the data set from 562 to 45 features. Okay, 562 features to 45 features we have reduced, and then we have used that data set to train the AI algorithm. Okay, so this is the way we train the AI algorithm, and we have used, we trained our AI model, machine learning model, using 3 machine learning techniques: k nearest neighbor, random forest, and stochastic gradient descent technique. But at the end, we found that random forest performs best compared to the other 2 techniques. Okay, so finally in our final system we have used the random forest technique for better accuracy. But we found that due to reduction of the dimension, that is the reduction of the feature of the data set, the accuracy of the machine learning based technique.
Sir, your slides are not moving, sir. Can you please recheck? Thank you, sir.
Sorry, my slides are not moving. Hello.
Yes, sir. Yes. Now it is moving, sir. Yes, right.
Now you can see my slide.
Yes, sir. Perfect.
Okay. Should I proceed?
Yes, sir. Yes.
Okay. Thank you. Now you can see my slide. Okay. So only the machine learning technique is not performing well, not giving the good accuracy. So because we have reduced dimension of the data set, what I told, the data set having dimension having 562 features, but we reduced the 562 features to 45 features for fast training of the machine learning algorithm. So the accuracy of the machine learning algorithm also falls. And accuracy we achieved around 70% or something like that. But without reduction of the dimension of the data set, the accuracy was giving around 80%. So later we decided, we do some literature survey, and we followed the existing research, and we found that only machine learning technique, if we use to classify, to identify the activity recognition, recognize the activity, it will not, the accuracy is not so high, accuracy is not so impressive. So we decided to include some experimental model with the machine learning technique, to integrate the experimental model with the machine learning technique, to improve the accuracy of the final system. So from the literature, we found that these two equations basically has been used as a mathematical model. These are the two final equations which basically used in our algorithm, along with the machine learning techniques, to improve accuracy. These two algorithms basically classify, basically been used to classify the acceleration data, or identify the activity in a more accurate manner with the machine learning technique. This experimental model basically acts as a catalyst to the machine learning model to improve accuracy. So we have used this experimental model with the machine learning technique, and then we found that yes, the accuracy of the activity recognition has reached around 90%. Okay, even more than 90% in some cases. So the existing works or other works solely depended on the machine learning technique, but to reduce the training time of our machine learning model, we reduce the dimension, so the training speed has improved, as well as that impose a negative effect on our machine learning technique. To overcome that negative effect, we integrated this mathematical model with the machine learning technique to provide the better accuracy, and finally we achieved that. So programming have three components. Programming part, this the software, that the AI software which we have implemented, which is basically running in the computer, that having three components, three parts: the serial communication, data processing, and classification. Serial communication, basically it establishes serial communication with the hardware and with the microcontroller unit, and getting the data from the microcontroller unit to the computer. Then data processing basically processing the data to be used in the machine learning model as well as the mathematical model, and finally the data, the generated data is being given to the classification model or classification component to classify and identify and recognize the behavior or activity of the user inside the smart home. This is the a pseudocode of the developed algorithm. This is the pseudocode for the developed algorithm. It basically summarizes how the algorithm, how the AI model, the developed AI system works to classify, to identify the activity of the occupant inside smart home. This is a picture from our test bed. Our system is very small, very miniaturized, and it can be where on waist of a person, or any part of the body. The best part of the using this system is on the waist, because it is mostly the central part of the body. It should be attached with the body, fixed with the body of a person using some belt, or some kind of it can be attached on the cloth of that person. Okay, but it should be fixed so that the device should not move here and there when the person will move around the room or do some different activity. Okay, finally the evolution. So we found that our proposed system, if we only use the machine learning technique in the proposed system, we are getting accuracy around 70% accuracy. Even some cases like walking upstairs, walking downstairs, we are receiving less than 70% accuracy. But when we are integrating our experimental model, mathematical model with along with the AI model, machine learning model, and the final system is giving much better accuracy, around 90% accuracy. Okay. So evolution, we compared the proposed technique with some other existing activity recognition techniques, and we found that our technique is giving the comparable accuracy with the other existing techniques. Not so good or not so bad compared to other existing techniques. Near similar accuracy compared to the other existing techniques. Okay, state of the art related techniques. So main benefit of our system lies in the cost benefit. Okay, that if you see the cost benefit of our proposed system, the cost per unit of our proposed system will be its cost performance ratio of our proposed system is much higher than the existing system, because the cost of the sensors or the devices for our system is much lower than the existing system. And our system can provide much better cost performance ratio with the comparable accuracy of the existing state of the art systems, state of the systems, and it will give the much lower cost compared to the other systems. Okay, that is the main benefit, that is the main advantage of our proposed system. So, in conclusion, this work put forward a new idea of categorizing human activities combined with human kinetics. The system can guarantee its basic stability and accuracy through multiple stages, including initial conception, design, implementation, and evolution. Our system still having some limitations. The system include insufficient experimental subject, because we have implemented the system in lab scale inside a lab. So we did not tested the system on large number of subjects. We need also our system what we have implemented so far, that is not so integrated. If we need to implement the system on a real smart home, we need to integrate system on a single device, small device. That is the limitation of this current limitation of the system. So if we plan to make it commercialized, the commercial available in the market, then we have to follow certain kind of procedures to make the system as a commercially viable. Okay, so these are the references which basically motivate and give the idea of this work. So thank you for listening to me, and these are my email IDs. So if you have any query, or if you want to work with me, or if you are interested to collaborate with me, so you can send email in this any of this email ID. I'll be happy to talk with you further regarding this topic and any other topic if you are interested on my research area. Okay, that's all from me.
Thank you, sir. It's been a pleasure hearing you. Next, we have with us Dr. Tripti Madam. Dr. Tripti Madam is a professor of computer applications from the National Institute of Technology, Bangalore. She published numerous books like Ambient Intelligence in Healthcare, Smart Innovation, Systems and Technologies, Unsupervised Learning for Gene Selection and Enrichment, and Automata Theory, Language and Computation, and many more. She also published numerous research papers, international conferences, and book chapters. Her research interest is not limited to focusing on understanding the implicit information from various biological omic data and leveraging machine learning algorithms for gene selection. Currently, she is extending research on machine learning, deep learning, data mining, computational biology, and medical image analysis. That's a short introduction about her. It's a pleasure having her as an eminent speaker of today's National One Day Conference. Over to Dr. Chittu Madam. Thank you. Dr. Tripti Madam, are you here? Hello, Madam. Hello, Madam. Dr. Tripti Madam, are you?
Yeah, I'm there. I'm there, ma'am.
Okay, Madam. I have introduced you. Now it's over to you. Please kindly go ahead with your presentation. Thank you, ma'am.
Yeah.
Ma'am, you can share your screen.
Yeah, ma'am. I'm doing that.
Okay, thank you, ma'am.
Is it visible?
Yes, ma'am, yes.
Okay. Thank you, ma'am. Thank you for your introduction.
Thank you,
Thanks for
ma'am.
giving me this opportunity. And as the thing is, I was just hearing our previous speaker, Dr. Pushpendukar. He has been very specific on the application side. So I will take you a dive into that. Basically, I work in healthcare sector using the machine learning and deep learning. So I will be focusing on how this machine learning has been helpful for the medical informatics. So let me start with it. So exploring AI is the topic of mine, pioneering the next digital frontier and its diverse application. So if you can see in my pictures itself, I have given certain things. So my main focus will be the different sources from where we collect the data, because whenever we talk about the machine learning or deep learning, it's very important to understand from where we get the data and what type of data we should process it. Because when we talk as a human being, we know that our maximum learning comes from our environment, the way we perceive the data. That is the how we process it and the outcome comes. So when we are trying to design something like intelligent creation, we have to be very focused on the data, which sir also was telling that the whole data was not relevant. So they did some feature selection and feature extraction techniques. So let me start with it. So it's a buzzword. People talk about big data. So the biggest question comes, what do we mean by big data? So big data is the realization of greater business intelligence by storing that data, by processing that data, by analyzing that data, and that was previously ignored due to the limitations of traditional data management technologies. We also know that in current scenario, we are so much of data are available through the different media. Now, if we are having those data, the biggest thing first comes, we all know, being a computer science background, that to process the data, the first very important thing is to store the data. So whenever we talk about big data, storing is one of the research field where people work. Second research field is processing. After it has been stored, the challenge comes in processing the data. Once you have processed the data, the third very important thing is how to analyze that data and take out the information from that data. So these are the four V's, which basically are defining the data to be a big data. First is the volume of the data. It's in terabytes. Then, so if you can see, It's not only the volume alone which defines the data to be a big data, but the another very important factor is the velocity with which we are getting the data. And we know that almost all of us are nowadays having the mobile, we are having the smartwatch. So you can just imagine that our data, how much, with what speed is coming in. So that is another important factor which defines the big data. Then comes the variety. We are not having the data in a single form, in some structured form. We are having the data in the form of text, we are having the data in the form of pictures, we are having the data in the form of speech. So there are the different ways. Nowadays, symbols people use. In the WhatsApp, if you will see, the lot of chatting is being done using the symbols. So everything is a data. So that is what also defines the data to be a big data. Very important thing now, when we are getting the data with such a huge volume, in such a variety form, with such a huge velocity, the important factor comes the veracity of the data. That the data what we are collecting, how important or how certain it is, how correct that data is there. So these are the 4 V's. Now people are talking about few more V's to define the big data, but they are the basic 4 V's which define your data to be a big data. So if you can see on the other side, one picture is I have shown that you are getting the data from the different sources, multiple data are coming. We are using some filters and then processing it. This filter is nothing but what we say the data pre-processing, because all data which we are collecting may not be of importance to us. Then if we are processing, because a huge amount of data if you are processing, and out of that a lot of things are of not informative, it is of no use to process it, because the process itself has got a high computational cost. So that is the importance of what we call the feature selection. So from the data we only try to select certain important informations, and that are being processed to get a knowledge gain. So thus on the another side where 3 people are sitting, you can see with this particular thing they came into the conclusion, let's shrink big data into small data and hope it magically becomes a great data. Yes, that is the whole importance of when we call the data collection and pre-processing that data is. So you can see over here there is a growth in data in 2010. If you can just see in zettabytes where it was, and in 2025 where it is expected. So when there is an exponential growth in the data, the next very important thing is, even if we have stored this data, the important things comes in our mind what to do with this data. There comes what we call the machine learning. So what is our, as being a human, what is our perception is humans have developed highly sophisticated skills for sensing their environment and taking actions according to what they observe. All of us are very sensitive to the environment, and that is the reason when even when we are kids we say that home is our first learning place, because the most of the data which is helping you to learn is from your home, from your parents, your grandparents, your friends, siblings, and all those things. Fine, next step, we go to the school. So, what we are doing is we are taking actions based on the data which we are sensing from the environment. For example, yes, we are very good in recognizing the face. Okay, it seems very easy, but it is one of the very difficult thing when you go to do a program related with face recognition. Understanding spoken words, we know that India is having so many states, each state is having their own languages. Okay, and then we are having national language. We have having one communication language. National language is Hindi and communication language is English. Each state people add their own essence when they speak our national language or when they speak English. Then also we are able to understand those things. For a small kid, mother is able to understand, parents are able to understand. So it seems very simple, but it is a very complicated process. Reading the handwriting, all of you are teachers, you can very well understand that as a teacher, one of the biggest challenge what we face is reading the handwriting of the students while examining their answer sheets. But still we do it, so we are good enough in doing that. Distinguishing fresh food from its smell, yes, by smelling we can come to know whether it is a fresh one or it is rotten, or whether one should take it, not take it. We would like to give similar capabilities to machine. That is that type of machine we want to design, which will have the similar type of abilities as a human being we are having. So, what is the thing which is making us to do all these things? It is something what is called intelligence. So, we all know that God has created many intelligent creatures, and above all, human being is being told as the most intelligent creature of God. Why we are intelligent? We are able to reason, we are able to plan something, we are able to solve problems, we think abstractly, we comprehend ideas, we use languages and to learn. Okay, so the ability to solve challenges is what intelligence is defined as. So when we want machine to work like a human being, we have to make the machine intelligence. May not be all, but it should have few of these properties to be called as intelligent algorithms. Okay. So intelligence dealing with challenges is to find best solution in the problem. So, what is artificial intelligence? So, something what God has given is a natural intelligence with which we are being blessed. Okay. But when we are trying to design a machine of that type, that becomes the artificial intelligence. So, artificial intelligence is commonly defined in textbook as the study and design of computing systems that understand their environment and act like human. So it is not something which you have just given and they are giving you the output, which normally in the algorithm analysis and design, we have certain optimal algorithms are there. No, it's not like that. It should continuously enhance its learning. And that is what we as a human being do. It's not that whatever our school has taught us or our parents have taught, that is throughout our life. We continuously from our environment, we learn and update yourself. That type of thing you want to be embedded into the machine. The term was introduced by John McCarthy in 1956 and in the well-known Dartmouth conference. So this artificial intelligence term was being given by him. So an AI accordingly is a system that possesses at least one, but not necessarily all of the skills listed in the previous one. So at least one of them it should have. So AI is the field of study that investigates theories and technologies for creating partially or completely intelligent systems. So I cannot say that it is we can design a machine with all these things, but at least if one of them you are having, you have designed a AI machine. Okay, so that is the reason it is being used a word partially or completely intelligent system. So, what is machine learning? It is different from that of the traditional computer programming. In machine learning, algorithms are in principle simple. The complexity lies in the data because the data is playing an important role. So it is not that you have written a procedure for a specific data. We have to write an algorithm which is learning from the data. Okay, is there a way that we can automatically learn that structure? That is what is the heart of the machine learning. So machine learning, you design the algorithms which learn from the data automatically, and that is very important in machine learning. First thing is to understand your data. How good is data? If data is good, the knowledge gained using the machine learning algorithm will be good. Okay, so Andrew Knack is the person, if you will search, you will get all his lectures over there about the machine learning, deep learning. So that is, a machine learning is about the construction and study of systems that can learn from data. This is very different from traditional computer programming. So that is what is the machine learning. So now the application of machine learnings, as sir was telling in few of the things, so it's not limited to one. You can apply the machine learning in almost all the fields. Okay, and that is the reason today everyone is talking about AI machine learning, because it has got its application not limited to a specific stream. It can be in the almost all the streams. So I basically focus on my medical data analysis. Now, the another important thing when we talk about machine learning, which people are now talking, is deep learning. Now, the question comes, when machine learning is already there, why to go for the deep learning? As I told, we are not the only intelligent creature. God has created many such one, but yes, we are the most intelligent. So when we, and our intelligence, everything lies with our human brain. Okay, so when we try to mimic the human brain, there comes that machine learning. Slowly we have confined to the deep learning. So deep learning is basically very much focused on how the human brain works. So that is the reason it is nothing but it is an extension of the neural network only. So the first thing which came, which is a very broad area, and somewhere in before 1950s people talked about artificial intelligence. Then came the machine learning, okay, which started somewhere back in 1980s, which was more on AI is something logical, reasoning was there. When this was being transformed into a mathematical form, there comes into the picture the machine learning. And when we are in the machine learning very much focused into the human brain, there comes the deep learning. So recently in 2010 only, the deep learning has come into the picture, and now everyone is talking about it. So in the past 10 years, machine learning and AI have shown tremendous progress. And the reason behind this is a lot of data is there. The computational cost has gone down because of the CPUs and GPUs. Now almost every one of us is having our laptop not only with CPUs, but it is also having the GPUs are there. So when the computational cost has become cheaper, people are thinking about analyzing a huge amount of data. Improvement of machine learning models. Yes, a lot of algorithms have come. Sir was talking about few of them, and there he told that the random forest was really working well for his problem statement. So yes, it's not a single, but multiple are there. So much of the current excitement concerns a subfield called the deep learning. Yes, the another thing is need. Why? What's the need of these type of enhancing learning techniques? The reason is big data is not smart data. We are having a huge amount of data, but the data is not a smart data. So we need to do some type of processing on those data and try to make it smart. So new data science methods needed for data growth, older learning algorithms under. So if you can see this, the below graph, with the increase in the size of the data, if you can see the traditional machine learning algorithm, up to some extent, there was exponential growth in the performance of the traditional machine learning models. But after a specific size of data, it performance didn't, it showed a linear growth in the performance. So there was not a further improvement in the performance of these models. That's the reason people thought of doing something which whose performance, because as a human being we know jitna how much data, if the data increases, our knowledge or performance also improves. Fine. So we wanted that there should be some algorithms who where there should be continuous growth in the performance with the increase in the data size. And that is the reason you can see with the deep learning that is happening. And that's the reason why people are talking about the deep learning, because traditional machine learning, after a specific size of data, there was no further improvement in the performance. So we went for the another algorithms, those are the deep learning algorithms. So, thus demystifying the buzzwords. So, hope all of you have understood the AI is the bigger umbrella. Within that is machine learning, and then comes the deep learning, which is very much focused on the neural network, and it is basically designed for unstructured data. Normally, the structured data can be very well done with machine learning algorithms. But when it comes to unstructured data, where the veracity of the data, variety of the data is quite high, then people can think about going to deep learning. But if you will see the previous slide, there up to some extent both of the algorithms perform well, and deep learning has got a higher computational cost. So it is advisable to first check the traditional machine learning algorithms. If they are performing well, no need to go to the deep learning. But if you are seeing that yes, no, it's not performing well, then you should go for the some complicated algorithm where the deep learning is definitely with a higher computational cost. Very important thing which is important is all the datas are not informative. So we need something what is called the feature engineering, which has got two factors: extraction, feature extraction, and feature selection. In feature selection, we do the selection from the existing one, we select few, whereas in a feature extraction, we try to derive a new set of features from the existing features. So the difference in the traditional machine learning and deep learning is, in traditional machine learning, feature extraction has to be explicitly done, and then comes the prediction algorithms. Whereas when we talk about deep learning, the deep learning algorithm has its has embedded the feature extraction and classification, that is the prediction together. So that is a basic another difference, because when you want to go for a feature extraction manually, you should understand which all algorithms are there, which all techniques are there. But here in the deep learning, that is inbuilt. That is the another reason people, because this needs little bit of domain expertise when you are going for traditional machine learning. But here with a very minimal domain knowledge, you can do the feature extraction and prediction together. As I told, I work on the medical domain, so big data in healthcare, yes, it has got. So whenever we talk about medicine, which resolves on pattern recognition, classification, and prediction, there are the three major things where the people working in medical domain focus. One is on the diagnosis, that is recognize and classify patterns in multivariate patient attributes. Therapy, select from available treatment methods based on effectiveness, suitability to the patient. And then prognosis, that is predict future outcome based on the previous experience and present condition. So these are the three main broad areas whenever we apply the machine learning techniques for the medical domain. So when it comes to the medical applications, it can be used for screening. It can be in the diagnosis stage, it can be in therapy, it can be in prognosis, monitoring the patients in biomedical or biological analysis, epidemiological studies, hospital management, medical instructions, and training. So medical informatics is nothing but when we try to apply the computational things to improve and facilitate the medical things, the accuracy, timeliness, and reliability of decision making. That is what is the medical informatics is. So when we talk about clinical decision makings, it helps in sound clinical decision, which requires right information, right time, and right format. Clinician face a surplus of informations. Yes, a lot of informations are coming to them. Now it is very important for them to understand which is of importance to them. They are ambiguous, incomplete, or poorly organized, rising tide of information, publicity, accessible online health information. Nowadays, we are so much aware that before going to doctor, we all Google about the symptoms we are facing. We gain some knowledge and then go to the doctor. Fine, so all these are nothing. They are the data which we are giving to the doctor. So doctor also has to find it out which is important data, which is not. Hundreds of pictures per scan for one patient. If you go for a CT scan, you can just see that how many multiple number of for a single scan there are different many number of scans are there. So when we talk about clinical decision making, the problem is man is an imperfect data processor. Yes, because we are sensitive to quantity and organization of information. If it is too large, huge amount of data, it becomes difficult for us to process it. Clinicians are particularly susceptible to errors when given too many. बहुत ज़्यादा अगर if you are giving the data, that is also difficult for a clinician to take the decision. Too few is also very difficult for them to come to some decision. And if the data is poorly organized, that also makes it susceptible for the clinicians to give erroneous results. For human, better performance requires more time to process. Yes, we can process, but require more time. In this, what will happen specifically in medical domain, अगर किसी को cancer है and you are taking 15-20 days time to properly diagnose it, उतने में क्या होगा? The disease will become something which you won't be able to control. You will lose the control of your SAT. So these are the different reasons why the AI is being talked about in healthcare, increasing individual health expenses. Almost every home is having a patient now. Larger geriatric population, we are having huge population imbalance between health force and patients, increasing global healthcare expenditure, continuous shortage of nursing and technician. We all have seen during the pandemic, during the COVID, this was the biggest challenge we faced. So AI is and will help medical practitioners efficiently achieve their tasks with minimal human intervention. I am not telling without human intervention. It is with minimal human intervention, a critical factor in meeting increasing patient demand. So these are the certain things which we can achieve when we bring the AI to the healthcare: improve accuracy of diagnosis, identify patient subgroups for personalized and precision medicine. People are talking about it when it comes to cancer, about the precision and personalized medicines, discover new medical knowledge. This was one of the reasons why we were able to we were able to come with the vaccine in a very short duration. Automate detection of relevant findings in pathology, radiology, etc., improve quality of care and population health outcome while reducing health costs, reduce medication errors and adverse event. So these are the reason why the AI is coming into the healthcare industry. So it's not only a computer science or engineering person can basically develop a good AI. It is a combination of all these people where we have to, and that is the reason this particular field is known as the multidisciplinary field. It is really a multidisciplinary because being an engineer, our knowledge to biology is very short. So we need to collaborate with doctors to basically come up with something which can be used by the medical. This is how the deep learning is now coming into the medical research. You can just see it is really going high. When we talk about it, there are two branches of AI. One is the virtual branch, another is the physical branch. And one very important thing is deep learning devices will never replace clinicians. We cannot replace doctors. We are there to assist the clinicians. So when we talk about virtual branch, it is basically the algorithms which are being developed and being embedded so that in the certain devices which helps the medical practitioners to better diagnose the thing. When we come about the physical branch, they are all the devices which are now in our body touch. So even the robots, they all come under the physical branch of AI in medicine. This is my small research group. Prior to joining to NIT Raipur, I was a faculty in Shiksha Anusandhan University, Bhubaneswar. I have recently joined NIT Raipur as a professor in February itself. So my whole and my that last 25 years, nearly more than 24 years, I have spent in Shiksha Anusandhan University. I did my PhD from IIT Kharagpur, and from there, this multiplicary disciplinary environment came into my mind, and I had a very good team in Shiksha Anusandhan. So you can just see these are my research scholars. This is the team of the doctors with whom I used to work when I was a faculty. Still, I am in collaboration with them, and this picture basically shows that as a technical person, there was a big joining of hand between both the groups. These are certain works being done by my undergraduate students as an intern at IIT Kharagpur. They developed a mammographic image corpus. So this was the corpus being designed by them, which basically helps a lot to the radiologist to automate their things and check it over there. This was the another image bank which was being created by my undergrad students in collaboration with IIT Kharagpur. That was a DICOM image bank. So this was the image bank being created. My first scholar. She is currently in France working as a faculty. She has done her postdoc also in France, and she worked on malaria parasite detection using the histopathological images. Microscopic images was being used, and this was the first work after me joining to Shiksha Anusandhan, completing my PhD, to work in collaboration with the doctors. She is the scholar who has worked with the genomics data integration, omics data, we say it, gene selection using omic data integration, and almost in all the work, these starting works, we have used the machine learning algorithms. She purely worked on the deep learning algorithms. She is currently ML engineer at AICTE Services Private Limited, Bangalore. She is a data scientist over there. So she worked on screening of oral cancer using deep learning for histopathological image analysis. She is currently a faculty in Shiksha Anusandhan University. She worked with the mammographic image analysis, and we collected few of the images from our radiology department in IMS. And she explored the different image processing and machine learning techniques on digital mammograms for early detection of malignant lesion in breast cancer. She is Subhashri Mahapatra. Her one of the co-guide was the doctor from gastrology department. He is the head of the department, Dr. Girish Pati. So he helped us in defining the problem, in providing us the data. She has done completely the deep learning algorithm for gastrointestinal disease detection using endoscopic images. They are the current three of my scholars affiliated under Shiksha Anusandhan University. Above two, they are the life science people. They are not from the computer science background. So they not only work on the dry lab, they also work on the wet lab. They collect the data from the hospital. They do give it for sequencing, and then they do the dry lab on that. So both of these, all three of them are basically working on antibiotic resistance gene identification. These two people, they are on the specific type of bacteria they are working, and he is working on the complete NGS data. He is a computer science background student. They two are my part-time scholars, and one of them is working on radiological image analysis using deep learning and radiomics with Internet of Medical Things. She is focusing on data augmentation because in medical imaging, the biggest challenge what we face is getting the data which are properly augmented, which are properly annotated. Fine. So, and when we are applying the deep learning, the data size has to be quite large. We also face a big challenge is the data imbalance is there. So she is basically focusing on that data augmentation in medical image analysis. With this, thank you to all of you. And if any question, I'll be really happy to answer it. If any question. Maybe I was either too good or you people have not understood anything. These are the two conclusions which I make as a teacher, that after a presentation, if there is no question, so there came maybe two categorizations. Yes?
Hello, ma'am.
Yeah.
Actually, my topic was very much good. Actually, we would like to get the PPT if you want to share with us, because very deep concepts are there.
Okay.
So there are so much things with the deep learning we never knew. So just we knew through you.
Thank
So
you.
just if you just give us the PPT, it will be helpful for us to more focus on it in later time.
Okay, fine. I'll just talk with, I think, Joy. He coordinated with me. Okay. So if any of the work you found it interesting, you can search my name in the Google Scholar or in the Scopus, and you will get all the papers available over there. So it will be good if I can be of any help to any of you. So if it is done, is it being done?
Yes, madam. Thank you for your awesome presentation. Now we have with us Dr. Diptendu Bhattacharya sir. He will be continuing his session after the lunch hours, and we shall see again at 2:30 or 2 p.m. Okay, so please stay tuned and be online. Thank you all for your
Thank
patience
you.
hearing. Thank you,
Thank
ma'am.
you.
Thank you for being there. Okay. Thank you, ma'am.